Hey everyone, today we're going to be taking a look at functionality of 3D transformations and perspective projection. So to get started, let's go ahead and take a look at some of the code. What we'll want to do is start by showing off some of the perspective projection. And in order to do that, I'll go ahead and demonstrate functionality of perspective projection of the standard cube that we were originally given in the project description. This consists of 12 lines, which you can see on the top part of the screen here. If we go ahead and compile and then run, you'll see our static cube being projected in 3 dimensions. We can also demonstrate functionality of perspective projection with a few other shapes. This is a triangular prism. The lines that compose of this triangular prism are demonstrated on screen here. And when we compile and run, we'll see that our triangular prism, not sure that I saved this. There we go. Once we compile and run, we'll see that our triangular prism is indeed showing up on screen. And we can even combine our cube and triangular prism, as I've done in this text file here. Apologies, it should be this text file here. And we can go ahead and show it running right here. And this should demonstrate, these 3 different objects should demonstrate that perspective projection does indeed work. Now that that's out of the way, we can go ahead and check some of the transformations of 3D objects. So we'll start with rotation. We can see that with the previous object, we can go ahead and rotate it about the x-axis, as so. And what you'll notice is that all of the axes are going to be a little bit different than what you would expect. That's simply because we are doing perspective projection on each of the axes as well. This is mentioned a little bit more thoroughly in the report. But we do see here that this is being rotated about what would be the x-axis for this particular projection. We can also rotate about the y and the z-axes. We'll start by demonstrating functionality of y rotation, which, as you can see, is now rotating about a different axis than it was earlier. We can similarly do the same thing for rotation about the z-axis. And what's interesting is that we can even rotate multiple different axes simultaneously. So if we wanted to rotate both the x, y, and z axes simultaneously, we could do that. And you'll see it rotating about all 3 axes. With that out of the way, let's go ahead and take a look at scaling. So for scaling, it's going to be quite similar to rotating. We'll begin by demonstrating scaling about the x-axis. So we're getting marginally bigger around the x-axis, and we just keep doing that until our figure gets extremely large. And indeed, you'll see that we do start getting a pretty large figure there. We can do the same thing about the y-axis. If we run here, and you'll see that we just keep getting longer and longer. And last but not least, we can demonstrate it via the z-axis. And we just keep getting taller and taller here. We can also scale about multiple different axes simultaneously and shrink them. So here we'll be shrinking about the x and the y axes while keeping the z-axis constant. And indeed, we do see that only the x's and the y's stay constant. That z-axis right there on screen, that stays constant. Sorry, the x and y's shrink. And last but not least, we can demonstrate translation. So here we'll be translating towards the positive x. So we should be moving to the left of the screen, because this is where the positive x resides according to the I-coordinate system. And just as with everything else, we can do this similarly for y. So running that, we'll see that we move forward towards the I in the I coordinate system when we translate our Y value. But of course, we can also translate multiple different axes simultaneously, and we can translate in the negative direction as we do here, moving in the negative Y and the negative Z. So we'll see the shape move away from us as opposed to closer to us, and we'll see it being translated across the Z as well, moving upwards. And indeed, that's exactly what we see here. All right, and of course we can do all of these things simultaneously, and I can go ahead and demonstrate that. Should make for an interesting viewing experience, but this really should be demonstrating that we can apply every single possible transformation and have them run simultaneously. All right, and that should be it. That demonstrates functionality of perspective projection and all possible 3D transformations using my code. Thanks for watching.